Hello everyone. Today is the 18th day of Leetcode 75 challenge. Let's begin with the 18th question. Question 1732. Find the highest altitude. The level of the problem is easy. I will request you to read the question beforehand as I will deep dive into the PPT and explain it in simpler way. Now let's understand the problem. So you are given an integer array gain. The name of the array is gain, which is of length n, which represents the altitude changes between consecutive points on a route trip. Okay, it basically represents a altitude change. Fine, these are the altitudes. Fine. So biker starts at altitude 0, point 0 always. That means okay. Now each value in gain of AI indicates that how much altitude changes when moving from point I to I plus 1. Let it be I point to I plus 1, right? So each value in gain of AI represents this thing. So a positive value in gain of AI means biker gains the altitude. A negative value means biker loses the altitude. Positive value means this way. Negative value means this way. The biker's altitude at any point is calculated by adding up all the previous altitude changes. Okay. So basically, whatever the altitude changes we had till here, we keep on summing it according to the question, and the newest which we get should be the sum of this plus the current one, right? Our task is to calculate the highest altitude the biker reaches at any point during the trip and return that value. Fine. The question is very simple. It just says that we have an array consisting of some altitude values which can be negative also and positive also. Okay, and we just have to sum up these altitudes which starts from 0, 0 plus this value, and this value will be basically addition of sum of this value plus this value. That's all. That's what question is asking. And the constraints are n is basically the length of the gain array, and n could be from 1 to 100, and gain values, the altitudes could be from negative 100 to positive 100. I hope you understood the explanation. Now let's move to the next slide. Let's understand the input output of the problem. Right? Okay. So here we are given 5, 1, 1, 5, 0, then minus 7. This is the array given, and these are the altitudes. Fine. So according to the question, it always starts from the 0. Bikers always start from the 0. Then he goes to minus 5. Fine. Then he goes to 1. Then he goes to 5 again, positive value. Then it's 0, right? So let 0 be somewhere between minus 5 and 1. Let it be somewhere here. Okay. Then again it goes to minus 7. So according to the array, the altitudes are like this, and the output is 1. How? So they were saying that it starts from 0, and it goes from I. Some goes from I to I plus. Okay. The sum goes like I to I plus 1, right? And the sum which we get is the summation of the previous altitudes plus the current one. Fine. That's what the our new array will be storing. So here the thing is it's starting from 0, right? So 0 minus 5 is minus 5. Great. Minus 5 goes up to 1. So minus 5 till now is a sum plus 1 gives me 4, minus 4. So till now total altitude is minus 4. Then from minus 4 it goes to 5. So it becomes 1 because minus 4 plus 5 is 1, right? So total altitude till now is 1. Then 1 to 0 will give me 1. 1 plus 0. It's a simple thing. Then 1 to minus 7 gives me 1 plus minus 7 plus minus minus becomes, right? So it becomes minus 6. Now from this I have to return the maximum altitude it reached, right? Which is what? Which is 1. Right? So we return 1. That's all. That is what the question is asking us. So it's written here, right? Calculate the highest altitude the biker reaches at any point during the trip. And also to note that every point is calculated by adding up all the previous altitude changes. Fine. These are the two main points you have to consider. And third main point is when moving from I to I plus 1, we keep on adding the things. We keep on adding the altitudes. Fine. This keep these 3 points in your mind. Fine. I hope you understood the explanation how we got 1 here. Right now, let's move to the next slide. To understand what problem is asking, we should build up an intuition to the problem. Let's imagine that you are tracking a biker journey. Okay, you are tracking a biker journey, and you are given a road trip map with different altitude changes, which is basically the gain area in our case. And our goal is to find the highest point you reach during the journey. Fine. Uh, the imagination is simple. Now, how you will do that? Okay. Now let's take the previous example for our intuition buildup. So if we take this -5, then I think it was 0. Okay, it was 1. Fine. It was 1. Then I remember it was 5. Then it was 0. Then it was -7. Okay, great. So we understood that we have to keep on adding the sum till the end. And whenever in which of the part altitude is highest, we have to return that. And always the biker will start at the beginning of the altitude, which is 0. Okay, let this be the part. Now, if you understand here what we are doing, just what is the thing happening? Okay, let me create an array here. What's happening is that I'll explain in the explanation of the problem that when we are going from I to I plus 1, we are adding the sum, right? When we're standing at 0, of course, the sum is 0 till now. Altitude is 0. Now, okay, fine. Now, when we move from I to I plus 1, what's happening? We have to sum up the values of the previous altitudes, right? Plus the current altitude, right? When we go from I to I plus 1. Previous is 5, 0, and now is -5. If we make the summation, we get -5. Fine. Now, current sum is -5 with us, right? So, but till now, if we compare these two values, the highest altitude is 0, right? So, let the ALT, which is altitude, let it be 0. Fine. Now, from -5, you go to I plus 1, which is 1, right? Which gives us -4. But altitude, then also the altitude is 0 is greater than this compared to -4 and 4, right? And the current sum will become -4. Fine. I hope you're understanding how we're building this thing. I'm just doing what the question asked us to do, nothing else. From here only, we will try to build up our intuition. Now, next step first, going from I to I plus 1. Fine. So here it is 5. So 5 plus -4 gives me 1, right? Okay, so sum becomes 1. Now, if you see, the greatest altitude previously was 0, but now 1 is greater than 0, right? So this will be our newest altitude or highest altitude. Now, when you move from 5 to I plus 1, which is 0, right? So what we do? So let me write it here, 1 also. Fine. Okay. So what you do? You just add 1 plus 0 equals to 1. Fine. So again, we got the same value 1. So we don't have to change the altitudes and the sum, right? Now, when you move from 0 to 7, it becomes -6. Okay. So here we will store 1 of previous one, and here -6 we will store, and the sum becomes -6. But the altitude is 1, right? So it is greater than all of the values, right? If you can see here, 1 is the greatest. So from here, if you can see what we are trying to do, we are adding the previous sum with the current value. That's all. And that's what we are doing. And then searching of the maximum altitude in this array, right? So if you can see, if current sum, let it be current sum and total sum, right? Total sum is 0 first, okay, and current sum is also 0. So when you start from 0, the total sum remains 0 and current sum also remains 0. But as soon as you go to the next step, what you do? You take -5 and you add it to the total sum, right? Okay. Now this total sum becomes -5. It's simple addition, that's nothing else. Now when you move ahead again, you get 1. You add this 1 with the total sum and it becomes -4, right? And similarly, you keep on moving and you keep on calculating the total sum and keep on adding it in the given array. Now, if you see, our array size was 3 plus 2, 5, but our output size is 3, 3, 6, right? Why? Because we are putting 0 in the starting point to calculate the sum because it is starting from the 0th altitude, right? So if we just read the theory, biker starts at sea level 0, okay, altitude 0. Now move through each altitude, change. We keep add the altitude change at each step to the current altitude and keep track of this altitude, right, which we were doing already. Keep track of the highest altitude reached. Each time you calculate a new altitude, compare it with the highest altitude found so far. Fine. It is higher than the previous maximum, update the maximum altitude, and now we continue until the end of the trip, right? Once all the altitudes change have processed, return the highest altitude recorded. This way, instead of storing all the altitudes, you can efficiently track, update the highest point reached. Now, if in this part I have not considered about taking an array, right? Extra array for storing the result. But for our understanding or building of the intuition, we can see that the array builds up to be in this case, right? But instead of building up the array, what if we just consider the sum, right? Since we don't have to return any array or stuff, we just have to return sum. Why we don't follow the same thing and store it in a variable named maxi or max? That is max. Fine. Currently max is 0. Then when we create the sum of 0 plus -5, what we get? We get -5. So -5 we cannot store it here, right? Because you know -5 is less than 4. When -5 goes to 1, it's -4. Again we cannot store. But as soon as -4 plus 5 happens, we get 1. So we store here 1, right? 1 plus 0, again 1. 1 plus -7, -6, we cannot store there. So we return this answer. Now, if you have understood how we are storing the max, I hope you understood the intuition build. This is the question of prefix sum, right? If anyone doesn't know about prefix sum or how prefix sum is calculated, don't worry, I will be explaining it in upcoming slides. But this is the way the intuition is being built. This is the concept of prefix sum. Prefix sum tells that let's take an array here 1, 2, 3, 4. Just keep it simple, right? Just for the small understanding. So what is the total sum? First of all, 1 plus 2, 3, 3 plus 3, 6, 6 plus 4, 10. Great, right? Then it will be 1, 1 plus 2, 3, 3 plus 3, 6, 6 plus 4, 10, right? I hope you understood what is prefix sum here, right? We're just adding the current value plus the previous value in our new array, right? And the end result or the end index is basically the total sum of the array itself. That's all. That is what is prefix sum in a nutshell, but I will explain you in more detail what is prefix sum in our upcoming slides. So if you can just relate this example with the one which we took earlier, which was I remembered as it is -5, then it was 1, then it was 5, then 0, then -7, right? And it was starting with 0. So 0 sum is here 0 minus 5, -5, right? -5 plus 1, -4, -4 plus 5, 1, 1 plus 0, 1, 1 plus -7, -6. And this is what we got. This is the prefix sum. As I explained you by taking example of 1, 2, 3, 4. Now, if you just add this complete array, what is the sum, right? -5 plus 1 -4 plus 5 gives me 1. 1 plus 0, gives me 1, and 1 plus minus 7 gives me minus 6. So the summation of this complete array is also minus 6. And what we got here is the same, right? I hope you understood the intuition, how we build up the intuition, and how we reached the conclusion that this is a question of prefix sum. Now let's move to the next slide. Before going to the approach, let's understand what is prefix and suffix sum concept, right? The prefix sum and suffix sum techniques are powerful approaches used to pre-process an array to answer range queries efficiently. Fine. They're particularly useful in problems related to the sum calculation over a range. How it works? Prefix sum. Pre-compute the prefix sum array. Prefix of I is basically prefix of I minus 1 plus array of I. If this is an array of prefix initialized with zeros, so we don't get any garbage values. And let's take an array of random values 1, 2, 3, 4. Prefix of I, let this be prefix of I, is basically prefix of I minus 1, right? Prefix of I minus 1, which is what? We don't have prefix of I minus 1. Now from that, what we can conclude? We should never start a prefix uh, from zeroth index, because in prefix, in 99% chances of cases, the zeroth index is value is always 0. Therefore, we always start prefix from index 1, because so that we can add 0 plus the value of array of I to prefix of I, right? Then this formula works. Prefix of I minus 1, if you're standing here, I minus 1 is this value, right? And array of I is 1, right? So value becomes 1. Then this comes here, I minus 1 is 1, prefix value, plus array of I is 2 here, right? So it becomes 3, 1 plus 2, 3. Then we come here, it's 3, right? And the prefix of I is, prefix I minus 1 is, its prefix is standing here, after that it's 3, right? So 3 plus 3 gives me 6. Then P moves ahead, this also moves ahead. Now previous value is 6, right? Plus the current value, which is 4 in the array of I, we get 10. And what is the summation of this array? 1 plus 2 plus 3 plus 4 is 10, right? What we got at the end? 10, right? This is what a prefix sum looks like query a range sum efficiently, sum of sub-array, right? This is one of the example of the question which you can take and understand the prefix concept. Now let's understand the suffix. Suffix is exactly the opposite of prefix and nothing else. Prefix calculates the sum from the front side or left to right, but suffix calculates from right to left. So if we take this as some array of suffix, let's take this and let's take an array. And what suffix is? Suffix says that suffix of I plus 1 plus array of I. And now there is a confusion. Why I plus 1? Right? Since we have to always initialize the suffix or prefix array with 0, so we don't get any garbage value. And always we will be starting, if we are starting from left to right, we will start from index 1. If we are starting from suffix right to left, we will be starting from this side, n minus 1 index. So that when I do suffix of I plus 1, it takes this value, an array of I, right, which is 3. So it becomes 3, correct? Now we move ahead here, and this value moves ahead. Now what? I plus 1 again, which is 3, and array of I is 2. We get 5 in this case. Fine. Now we are in the starting index of both. So I plus 1 is 5 when we are standing in the starting index, plus 1 of the array, we get 6. Now what is the total sum of this array? 1 plus 2 plus 3, 6, right? So we're getting 6 in the first index and third in the last index, right? So this is how suffix works, and some of the you can calculate or you can understand the concept by doing the question sum of sub array. left to right suffix, of just implementing the same question in the way of suffix is implemented. That's all. So this is what how suffix and prefix works, and why is it efficient? Instead of recalculating the sum for every query, prefix and suffix sum allow O of one query after O of n pre-processing. For example, if you wanted to calculate the sum from 0 to suppose third index, and again another query is there 0 to 4, right? Let it be query 1 and let it be query 2. So you don't have to calculate again and again. Instead, like here, we will store the sum from 0 to third index in the prefix array and 0 to 4 in the prefix array. So when we go to the fourth index of prefix, we will be knowing that the fourth index value is the summation of 0 to 4, right? Also, I will try to explain you one more thing in the prefix array is that suppose this is an array given to us, fine, 4, 5, and 6, right? And when you create a prefix array is usually of this type, 3, 4, 5, 6. Then when we create the summations of this in prefix array, the resulted will be 1 plus 1 comes here, 1 plus 2, 3, 3 plus 3, 6, 6 plus 4, 10, 10 plus 5, 15, 15 plus 6, 21, correct? And also the summation of, and also if you see the summation of this array is 21, fine. Now this also indicates one more thing, so that we don't have to iterate again and again to find what could be the sum from index 0 to suppose index 3 or from index 0 to index 6, fine. That what helps us in prefix array, we don't have to calculate that again and again because we already know that at index 0 sum is 1, at index from 0 to index 1 sum will be 3, from index 0 to index 0 1 2 3 0 1 2 3 will be sum will be 10, right? And if you take want to calculate the sum from index 0 to last index, the sum will be 21. And also this question could be modified, like there could be some scenarios calculating the sum from index this to index this, right? In that cases also prefix sum helps us a lot, right? I hope you understood how prefix and suffix is working. Now let's move to the next slide. Variations of prefix and suffix sum, right? Prefix sum of fixed window. Index sum of every subarray of size k using prefix of in O of one time, one thing. And two pointer variation with prefix sum. Use prefix sum with two pointers to optimize problems like subarray sum within a range. Fine. Now, if you're confused that I have not talked about suffix, look, what a prefix can do, a suffix can also do the same thing, right? Just the difference is that prefix starts from left to right and suffix starts from right to left. That's all. And depends upon the question, which concept you are using there and what the question is asking, right? So these are the variations of the prefix and suffix sums you can use. Now let's move to the next slide. Where prefix and suffix sum is used, fine. It can be used in subarray or subsequence problems like sum of a given range. Check if subarray sum equals a target. Then string problems, cumulative frequency count using prefix sum, efficient substring hashings. There could be pairing and range problems like finding equilibrium index in an array, number of subarrays with a sum in given range, or frequency count, prefix of XOR for subarrays or queries, or suffix if needed. Find anagrams using prefix frequency count. These are the questions you can Google, the type of questions you can get where we use prefix and suffix, right? I hope you understood the concept of prefix and suffix. Now let's move to the next slide. Now, since you get the intuition of the problem, let's look into the approach, how we're going to solve it. Right? The approach is exactly the same as the intuition we discussed, right? Though we won't be creating a prefix array, as I said in the intuition, we will just be storing the maximum altitude. That's all, right? Now let's understand the approach. The prefix is will be starting from 0. This gives a track of the current altitude. Answer stores the highest altitude found so far. Okay, this is a defining of the variables. That's all. And iterate through the gain array. For each gain, we update the prefix by adding the gain of I to it, which is the prefix sum. And we check if prefix is greater than the answer, then we update the answer also, right? So when we are going through the array, at each point, we update the prefix like a prefix sum, right? And in answer, we check whether answer is smaller than prefix or not. If it is, answer becomes prefix, right? And at the end, we return the after processing the complete array, we return the answer which contains the highest altitude reached, right? The approach is very systematic and very easy to understand. Now, how prefix sum is helping us? Biker's altitude at any point I is sum of all the previous gain values. I assume and I hope that you understand till this point or at this point what does sum of previous gain values means in particular index I at prefix array, fine, which is exactly how prefix sum works. Instead of recomputing the altitude from scratch each time, we efficiently update it using cumulative additions, reducing the unnecessary calculation. For example, if the complexity could have been more than O of 1, but it boils down to O of n using prefix sum, right? Now let's move to the next slide. The code is exact copy of the approach we discussed. Let's understand it line by line. N stores the length of the gain array. Prefix stores the current prefix altitude sum, and answer is the maximum altitude we reached. We loop through the array. We keep on adding the prefix sum. We check whether prefix between comparison with prefix and answer, whether prefix is maximum or answer is maximum. And at the end, we return answer, right? And this complete code takes only O of n complexity because first of all, we are using prefix sum, which takes O of n solution, right? If you are not taking this in consideration, just look it in that way that we are just iterating one time. Iterating, we are iterating the array O of n times. That's all. That's why the complexity is O of n. And space complexity is O of 1 because we are not using any data structure to store the answer. I just using answer variable which takes constant space. Now let's move to the next slide. Now since we have the understanding of the code, let's look at the dry run of the example. Okay. So let me write it down here. -4, -3, -2, -1, 4, 3, 2. Its sum is 0. Its maximum altitude is 0, right? According to our question or our solution which we created, prefix is the current sum which we are getting till now, and answer is our result. Fine. So what we do first, 0 plus -4 gives us -4, right? And answer, we compare it with the answer, answer is 0, which is greater than -4, so move ahead. -3 plus -4, we write it here. -3, we added -3. How much it gives? It gives -7, right? So it becomes, prefix become -7. So basically till index 1, total sum is -7. -7, I will edit here, but -7 plus -2 gives me -9 when we are in this index after that. So this becomes -9. Again, it comes here so this is -9, right? So -9 plus -1 -10, right? So we update this prefix sum again to -10. Again, it goes to next index. Here the value is 4. Okay, so we add 4. What we get? We get -6. So our current sum of prefix is -6, but still it is less than 0, right? We move ahead to 3. We add 3 to this -6. We get -3, still smaller than answer, right? Then again we move to 2, last index. We get -1, which is also less than 0, and the iteration is completed, right? So our answer comes out to be 0. So this is the maximum altitude reached by the biker in the gain array. So I hope you understood the dry run. If you have any doubts or confusion about the solution we arrived at, and how we arrived at it. I would suggest going back and understanding the intuition and the concept slide of prefix and suffix summations and the approach and then the code. After that, do a dry run by yourself on 2 3 examples, and I'm pretty sure you will understand both the solution and the thought process behind it. Now let's move to the next slide. Now, since you're familiar with the problem and the solution, let's move to the lead code and code the solution. We will take n to store the length of the gain array given. After that, we will take prefix variable to store the prefix sum, answer to store the final result. We will iterate through the gain array. We'll add the value to the prefix. Answer will have the max of answer comma prefix, and we will return answer. Now let's submit the solution and see the test case passes or not. Okay, now let's submit the solution. We have successfully submitted our solution. Now, code of the problem is available in my GitHub repository. You can find the link in the description. Thank you, everyone.